Yeah, I already did it. Oh, okay. Yeah. So, great. During this session, we are going to talk about monitoring and alerting and why it is really important in modern applications. This is agenda, what we are going to cover. Expectations. Yeah. So, generally, why monitoring and alerting is really important? Because usually when you're developing your applications, you cannot see what's going on inside, and just at any time something can go wrong, obviously, and it will definitely go wrong one day. So you should somehow to see what's happening in your application and how to deal with it. So there are three main types of monitoring. It's infrastructure monitoring, tracks servers, containers, network. It's like what generally, for example, going on in your Kubernetes cluster, how many CPU it consumes, how many memory it consumes, and so on. Application monitoring can help you to track application performance, how long your methods executes. It's not working. Okay. Nice. How long your methods executes, how long your SQL queries executes, and so on. And log monitoring helps you to analyze and aggregate logs for patterns and errors. There are two models of getting monitor metrics from your application. It's push and pull model, and it depends on your case what model you're going to use. General in push model, a lot of agents like your microservices pushes metrics and logs to central server. For example, it can be useful with serverless function, Internet of Things, or edge devices, for example. And pull model, and it is where your agents, your microservices exposes different metric endpoints, and central server comes and grab all these metrics by itself. So we, for example, in our projects, uses the combination of push and pull model for different metrics like HTTP requests and what we are going to visualize in Grafana. We are using pull model. We're exposing metrics endpoints and Scrapper comes and grab all these metrics by itself. And for different traces and application performance monitoring, we are using a push model. We use like APM framework to get all different spans, traces inside the application, and pushes all this stuff into our central server. So there are different monitoring cloud systems, three, the most popular one, like AWS CloudWatch, Azure Monitor, Google Cloud Operations Suite. I haven't worked directly with all these things, so our DevOps engineers care about this, fortunately. Let's talk a little bit about OpenTelemetry overview. So OpenTelemetry, it's a unified standard for telemetry data collection. There are a lot of different libraries and solutions that helps you to collect your telemetry inside the application. For example, for Python, it could be different Python libraries. For Java, Golang, it could be other libraries, and they don't have a unified standard, and you should always to have custom setup for each library. It's not very convenient. So OpenTelemetry provides us a unified format standards that helps to collect all these traces, metrics, logs, and send them to our databases for analytics in simple and unified way, like this. So this is how like general flow of OpenTelemetry looks like. So different services can send data using different protocols like OTLP, Jagger, Prometheus for traces, logs, and metrics, and OpenTelemetry collector processes all this data and sends to the backend. Backend means like any data source for storing these logs, traces, and metrics. And after this, this backend, you can use this backend to grab all this data and visualize it using different visualization tools. Yeah, this is more detailed view. So application sends metric data to OpenTelemetry collector. It exports, for example, metrics in Prometheus format to Prometheus data source. And using Grafana, you can query all this data and build awesome visualizations for your projects. It could be different data sources, as I mentioned before. Prometheus was one of the most popular, so I haven't used others. So we used Prometheus or Victoria Metrics for collecting our data. And yeah, you have a question.
Like in the previous graph, I actually didn't use the Prometheus. I only have heard about that. So I have a question here, but did the Prometheus uses the export from the OpenTelemetry, or does it format it in the form? Because like in the previous graph, you were showing that the data from the Prometheus is pushed to the Open.
Here is like Prometheus format, like logs, metrics in Prometheus formats. And here is export data to Prometheus data storage. So here we can use Prometheus data store to store all this data, and this data is in Prometheus format, like this.
So there's the OpenTelemetry format, and then there's the Prometheus format. It's just the data format.
Yeah.
Okay. I'm just basically just saying the same exact thing he said. I'm just emphasizing the format.
Yeah, format.
There's the Prometheus format, and there's the Prometheus software. This is showing the Prometheus software. The previous one was data coming in Prometheus format. Because Prometheus has its own data format, which is very similar to OpenTelemetry, just a little different.
Yeah. So, and visualization tools, Grafana for metrics visualization, usually Kibana for logs visualization, and for example, Elastic APM for traces visualization, where you can search for your traces and split it into spans and check how long each method inside your business logic was processed. And for alerting system, we can use Prometheus Alert Manager, PagerDuty software, and Ops Genie for incident response. It's Atlassian solution. Yeah, Alert Manager helps to manage all alerts in the Prometheus stack. And also you can send all this data to PagerDuty and set up like on-duty persons. And these persons will be called at any time just to fix the incident on production services. Yeah, the best practices for alerting, for alert design is you should focus on actionable alerts only. Use threshold to minimize false positive. It is really important to design your alert not to trigger on different not important things. And you should use labeling, obviously, to search for alerts in a comfortable way. Prioritize critical alerts, and you should really carefully test your alerts in test environments, because if you set your alerts wrong, set up your alert wrong, pager on-duty person will be alerted at night, and next day this person will be really angry on you. Yeah. So, summary. I hope you right now understand that alerting and monitoring is really important, and you should set up it in each production-ready applications. But now it is pretty easy to set up for your pet projects or your home projects. So it's not a big deal to set up these things, but you will be you will know all and everything what's going on with your application. It will be easier to debug, to search problems and issues inside your business logic, or what's going on with your infrastructure and so on. So before and after, after questions, we're going to make small setup for demonstration, how it works, how you can expose your metrics, how you will visualize it, and how Alert Manager works. We are going to connect Alert Manager to Discord channel. So if you have any questions about monitoring and alerting, you can ask right now before we go into our practice. Great. So no questions, right? Okay. Let's go to practice. Before practice, we need initial setup, and we need to be sure that everything works well. So monitoring infrastructure needs a Docker network to be run correctly. So we need to be sure that you have this network created. So check this network in your network list. If it not exists, please create using this command, Docker network create, and we will go further. If you have any questions, you can raise the hands. I will help you to run it fast.
If we don't have it, nothing's just going to show up. Or
You don't have network, or you don't?
if we run the network list command,
Yeah.
and if nothing shows up, then that means we don't have anything.
Yes. If you don't have Seollal Bootcamp 2025 backend network in your list, you should create it.
Oh, backend, then it's _default.
It's wrong network. Yeah.
So you can probably ignore it.
Yeah. Who haven't done it yet? Okay. Do you need help? No. Oh, okay. 1, 2, 3. Who haven't done it yet? Everyone have network created? Okay, let's go next. So in your Python backend project, you should create one more road. It should look like this in a project structure, like metrics.py. And put, please, yeah, let's just create metrics.py in your roads. And add these new libraries in your PyProject toml. Yeah. Sorry? Okay. Okay. Okay, let's go next. So, and inside this new metrics.py file, please add this code. Let me send it just for copy paste. Okay. Without this code. Okay. So after this, add these 2 lines before main function to activate your metrics and expose it in this file. Let me send it also. Not to spend too much time. Okay. Also, you need to import these packages from new libraries. I guess your idea will help you to do this. Does anyone need help? Imports. Yeah. Also, these imports could be unspecified. You need to make pip install. Like this. To install all new libraries and set up your new roads. Didn't help? Up. This one.
What's the definition of like fixed file? The one
Does anyone need help? We can go to the next part, right? Okay. Okay. So pip install done. Now let's run the backend server, and we will check it for that our metrics is exposed correctly. Be sure that the network is Seollal Bootcamp 2025 backend, like this. And if you have different ports here, it depends on your Docker file. Also be sure that they're correctly set up. Let me run it on my computer. Well, let's check it. After you run your backends, and you can go to the browser and search for localhost 8080 metrics, and you will show all these things. This is your metrics.
So the run code again? Run code? So command?
Okay. I will show you in presentation. If you have problems, raise the hands.
Is monitor, is for monitoring, right?
Yeah.
I need to give the Docker.
Yeah, you can use your previous image to run. Just connect it to your network, to this network. That's it. Yeah. I forgot one important thing. You should rebuild your container. Yeah, you're right. Just Let me show. Yeah, before running your container, execute, please, these commands to rebuild it. And after this, everything should work.
Yeah, 18. Works?
So everyone see, everyone see these metrics in your browser? Or
For just the case. Yeah, yeah. Speaking yeah.
This one. Okay. So let's try to get to the next steps. Git clone this repository with the infrastructure. If you have this repository, just make git pull on your main branch. Nine minutes. Uh, Okay, after cloning, let's go to this project and just run Docker Compose up. Later, we can briefly go through all these files and I will explain what's happening. So this is endpoints, or not endpoints, just ports for your Prometheus, Alert Manager, and Grafana. Everything should work. Also, you can see these endpoints in your using command line like this. So 8080 for our Prometheus, 3000 for Grafana, and 8083 for our alerts. Great. So also it should be pre-configured dashboards here, Fast API observability and Python process monitoring dashboard. Later you can play with it if you want. So here we can see different metrics. It's just for demonstration. Requests per seconds, get requests, average duration, successful requests, failed requests, 99 percentile. It's more advanced topic, so we're not going to cover it today. Something like that. So if you have problems, raise the hands. We will stop it, especially for you. Yeah. Here we can also check our health. You can see that our backend server works well, stayed up. I guess we can close. I don't know. So, and now let's try to generate bad metrics to trigger our alert. So for alerting, we have 4 rules. These rules defined in alert rules file here. This file mounted to our Prometheus. And here we can describe like expression to trigger this alert. This expression is based on our metrics. Yeah. So let's try to trigger 400 error codes. Let's put 2. Not 2. And let's see how it works. So we started generating our not found codes here. In observability, we can check that the rate of error requests go up. 2. Let's generate more and make it stable. Stable wrong. So now we can see that this alert start pending. Let's wait a little bit more because we said, I guess, 1 minute for this error rate. Maybe let's check it. Yeah, 1 minute rate. So it's still pending. Have you launched infrastructure things with Grafana, Prometheus? You have a question, yeah. Okay. Yeah, we forgot to add data source in Grafana, so let's follow these steps. Should be fast. Navigate to connections, data sources here. And add new data source Prometheus. Should be like this. And don't forget to put your container name, not localhost. And that's it.
I thought you had it already.
I had.
So,
Yeah.
How did you get the graph?
Yeah, I had, but no one, because it not be configured using no code.
Gotcha.
So save and test your like data source. Is it clear for you to how to add data source?
Yeah. What should you do
After that, everything should work, and you will see like graphs, these metrics in your dashboard. After adding data source, maybe it is good to restart your containers using this one, these commands. So do you have problems or everything's okay? For Grafana? Or for what? Username, password? For Grafana? Or what service? It should be like default admin like this.
So when we connected to Prometheus, you said the name was the Docker.
Yeah, data source name should be to connect Grafana to Prometheus should be container name, like HTTP / Prometheus and the port of Prometheus. Yeah, here we can see the firing that we triggered our alert with the error rate. Let's check our Discord. It should be here. Let's wait. Yeah. So we got the message from our alert manager to our Discord. So if you have developer team, everyone could see it. And if you have a pager on duty software, so after this will be triggered, special robots will call on duty persons and will tell that it is high HTTP rate on backend server. So let's please check it, what's going wrong. And if the error rate goes down, the alert will be resolved automatically after a couple of minutes or maybe after 1 minute. It depends on your setup here. Well, I guess we can finish. You can play it with it like at home if you want. We don't have enough time to check all these files, but let's do it really fast. So Grafana folder has pre-compiled, predefined dashboards. You can check it here. It's like configuration as a code solution. We just mount these JSON files to our Grafana source. Alert rules. Provisioning, it's just rules. This file says that we have predefined dashboards, and these dashboards can be modified. So we do it because we don't want someone to modify dashboard from the user interface, because we have all these dashboards inside our, for example, infrastructure repository and under source control. So we should change all things only from using code. Alert rules to describe your alerts and expressions and other different settings for it. Alert manager, this configuration file for your alerting. And here we define receivers. For example, here is Discord receiver. I made this webhook, and that's why we can see this message here. And Prometheus YAML, here we're defining our Prometheus settings. All works using Docker Compose. So here we're defining all our services and volumes for it, exposing ports and so on. That's it, I guess. If you have time after this presentation and you want to set up everything correctly, we can do it. I guess 15 minutes. So
summarize what changes we did.
Changes?
Yeah. After.
Yeah. Let's summarize what generally happens. So we used Prometheus Fast API Instrumenter. It's one of the lib for instrumenting your Fast API server. As I mentioned in presentation, it could be different libraries, like for each language, it could be different. So that's why OpenTelemetry comes into game, but we are not going to use OpenTelemetry here just for, because we need simple example, like simple setup. So we're just using Instrumenter, fast API. We exposed metrics endpoints for this Instrumenter that allows us to show these all metrics here. Then we ran Prometheus, and Prometheus comes to our server, to our backend server, using, let me show, Prometheus. Yeah, we defined scrape config here, and we told Prometheus, go to this URL and get metrics from it. That's it. So after this, we set it Grafana.
Name of the container, right?
Yeah, name of container here, because everything is inside our Docker network. So after this, we launched Grafana and connected also to this network. So, and manually we added data source, this one. And after this, Grafana can go to Prometheus data source to get all these metrics and visualize it. So if you open dashboard, for example, this one, oh, let's just add new dashboard, add visualization, data source. Yeah, we can like open this one, get any metrics from it, and try to query. Yeah, we can see this metrics exists, but we should use different like aggregation functions to visualize it correctly. So it's just for demonstration. So in Grafana, we just query all data Prometheus collected from our backend side. So in Prometheus, I guess we also can query all this stuff. Yeah. So Grafana do the same, but from Grafana side. Yeah, that's it.
Then we got an alert.
Yeah.
And what should we have to do that?
After alerting, it depends on alerts. If it depends what happening in your server. Like if it is 500 error rates or some integration not works, or maybe null pointer exception in your business logic code, or something goes wrong, you just check this alert, see what's happening, and after this, you will go to Kibana or any other log management system where you can check logs. Filter these logs by errors, figure out what's happening, and after this, you like it's just research and make fast fix, hot fix like this, and push to production as soon as possible. Yeah, here we can see that our high error rate alert was resolved because the error rate gone down. Let's check it. Yeah, so we don't have any problems right now. Hmm?
It's resolved.
Yeah, it resolved. We not see any problems right now. So for 1 minute, for example, or you can set up at 10 minutes, no problems. 5 minutes, we have no problems. So that alert was resolved. We can check 6 hours. Here was high error rates. Yeah, a lot of problems. Cool. We can finish, I guess. Yeah. If you have any questions, let's. Yeah.
Let's take a quick 3-minute break and then we'll do the final session.
Yeah.